Let's say we have a chemical reaction and the amine is a product and we want to purify this amine. So in a chemical reaction we can have a lot of side products. There can be a lot of other crap in there that we don't want. We need to get rid of that stuff. So here's a method of purifying an amine using its salt. If we have an amine and it becomes protonated, it becomes what is known as an amine salt. And an amine salt is much more soluble in things that are polar than in its previous state where it is not protonated. So we're going to use this idea to separate it from the other crap from our reaction. So this is something very common in pharmaceutical synthesis. If you've ever done a synthesis like that, you may have actually done it and not even realize what it is you were doing. So it's important to know this because it'll help you maximize your yields and just cut out all the impurities and garbage that you don't want in there. So this can be done in a lot of different ways. This example is going to be done with ether and water. So the idea is we have two different mediums. In the ether medium, it is polar, and polar things can dissolve in it, but it's not as polar as water. So the highly polarized thing. So if we mix our chemical, after we've had our reaction, we've got some products, we're going to mix it into this, a mixture of ether and water, and they're going to separate. The ether is going to be on the top, and the water is going to be on the bottom. Ether is less dense than water. And what will happen when we pour the contents of our reaction into here, it's going to separate. The stuff that is more polar is going to be dissolved in the water, and the stuff that is less polar is going to be in the ether. So let's say we have an amine that is less polar, something that has a lot of carbon. So here I've got something that's NR3, so it's got three carbons attached to it. Water's not able to approach it as easily. So this will be in the ether phase with other organics, and then any salts and other more polar crap is going to be in the water. So the first step is going to be to remove the water phase. So we just open this tap here to pour out that stuff, and then what we'll do is add more water. So what should happen is we'll get rid of all of this salts and other polar crap that's been dissolved. And another thing that's important to know too is that you should probably do this a few times, because you may have something that is in equilibrium. So say we've got A is in equilibrium with B, and let's just, to keep it simple, say it's 50%. So half of it's A, half of it's B. Let's say A is in the ether phase and B is in the water phase. If I pour out all the water and then I add some fresh water in there, what will happen is that all of B will be gone, but since it's in equilibrium, once more water is there, half of A, 50% of A will become B. So I'm going to have more stuff in there. So you may want to do it more than once, just to, in case there is an equilibrium or something else, just to do it multiple times, especially with the water as opposed to ether, because water is cheap. So this is not going to be costly, and it's just going to prevent any impurities and things in there messing up your reaction later on. So it's you can skip it if you want. I've seen people do stuff like this only once, and I always do it multiple times if I'm going to do it, just because of that. It doesn't cost much. So we've got that. After we got that out of the way, we've gotten rid of all of the polar crap, and now the next step is going to be to, again, add the water, but then add dilute acid. It can be hydrochloric acid. I just put hydrochloric acid in this example. When I add dilute acid and then shake this thing up, what will happen is that the amine will become protein. It will become an amine salt. Once it becomes an amine salt, it's going to become more soluble, and it will enter the water phase in the second stage. So now we've got rid of all of the polar crap. There's not anything in this water, anything significant anyways. When we mix hydrochloric acid with this will become polar. Now the only thing that's going to be in the water phase is the amine salt. So now what we can do is get rid of the ether phase. So we get rid of this, it's going to have all the other less polar garbage that's left. Remove the ether, add fresh ether, and then add NaOH. So what that's going to do is just remove this proton, and then the amine that we're looking for will migrate back into the ether layer, and we have a purified amine. Then with an ether that's easy enough to distill off, you can probably just leave it in open air, or just put it, or just do a vacuum. Just put it in a vacuum and it will just evaporate basically, and you'll be left with the amine. And you don't need to do multiple. You don't have to worry about the equilibrium for the ether. You only need to do that one time. I recommend doing it in the water phase because water is cheap, ether is expensive. So there you have it. At the end, you've got the amine by itself. And again, first get rid of all the polar crap, add more water, add acid. This goes to the water phase. Get rid of the less polar crap, add ether, add NaOH, removes the proton, got the amine. Easy as pie.